Welcome back to another Rust programming video. Today we're going to be adding encryption to an AV1 video steganography project. So just for a little background, if you guys aren't familiar with steganography, it's the process of hiding messages sort of in plain sight. So this goes way back to, I think, the 4th century BC, where they wanted to transmit a secret message. And so they shaved this guy's head, tattooed the message on there, let the hair grow back, and then they waited, sent him on his way. And when he got to the other side, they shaved the head and revealed the message. And of course, on the way there, no one knew to look on his scalp, right? So the message was hidden secretly. Another form of doing this on a more modern thing and for images is just modifying the lowest value. So like very often your images, you just have a big bitmap of all your pixels, right? A lot of times you'll store this in RGB or there's some other formats. And if you imagine, we actually can modify this lowest bit to include our message, right? We can basically include if we have an ASCII message, we can take each bit and set it to either a 1 or a 0. And that actually won't affect the output image very much, right? Because these are the least significant bits. And so because of that, like visually, you won't be able to tell there's a hidden message at all. So we're going to be doing that with video today, which makes things a little more complicated. We can't just change these bit values because there's compression, lossy compression that'll step on our toes. Luckily, there's this excellent paper that kind of gets into how to do this with AV1. And sort of their approach is to use, there's these infra prediction angles between frames that kind of tell you how the objects move and rotate. And so, yeah, they kind of talk about the normal LSB encoding and how that doesn't work for video. But basically their approach is these angle values can only be these set things, right? And when it's actually encoded in the AV1 video stream, it's encoded as these values. And so basically what they want to do is modify these values to include the message. And so there's some special cases of like if it's 6, obviously it's the max, right? So you can't add a 1 onto that. So basically they skip 6 and then, if they want it to be a 1, they add a 1 to odd values and then they subtract a 1 from even values. So yeah, if you look at this, if let's say we have this source angle stream, right? And we want to encode this message, you can see how this maps on. This is 0, so this is unchanged. This is odd, so we don't touch it even though it's a 1. Same thing here, this is odd with a 1, so we don't touch it. And then this one we actually do subtract down to 4 because it's 0. And so I have, luckily the paper, they open source their code. So I have, this is their fork of basically implementing those changes into RAVE1, which is like a Rust AV1 encoder that we're going to be using. And so I've taken the time to kind of re-implement that diff on the latest version of RAVE1 so we can get some nice performance improvements. And so I can run the example here of basically eventually we want to encrypt this in addition to just including in the bit stream. And so basically we're just running the binary that'll encode this. This is the source file we're taking in. We're going to export it here and then we're going to hide this string in it with these parameters. This is basically how often you change the bit, so you can kind of stretch out the stream to make it less obvious. So if I run this guy, it'll take a little bit to run, and we can take a look at so this, whoops, that's the wrong one. It's going to be Y4M. So yeah, this is the source video we're modifying, right? You can see it's just a normal drone video. It's very high resolution, so we have a nice big file to inject these bits in. And yeah, so if I pop over, we also have, we of course need a decoder, right? So there's this one that's pretty good. There aren't any in Rust that I've seen that are pretty popular, unfortunately. This is a different one than what the paper implemented theirs in. But yeah, I've just implemented that same diff for basically looking at those angles and extracting the actual values. So we can actually run this. Basically this command is telling it, we're going to dump the hidden message we find to this file. We're giving it, this is the file that this guy is writing to here. It's almost done. And then we don't care about the actual frames. We just want to extract the message. And then the paper also gives us this Python script, which basically just dumps out the actual message. And so if I run this guy, you can see there's our message, right? And so it kind of processes it one at a time, right? These are injected each bit one at a time into each of the angles if it can. And so I can actually prove to you, there we go. I can prove to you that this works if we just change this message to like hello YouTube, right? And I overwrite it. And you can see it injects the message very fast. So actually we have a lot of bandwidth to play with here. Which is basically I want to get this running in real time to use as like a network socket, as well as doing like a Diffie-Hellman between kind of a fake client and a server to exchange this. So you can see it deconstructed it to the bits of the message and it injected them. And so actually I can jump over, even though it's writing out the end of the file, we can still read the first part of it, and you can see we get hello YouTube. The problem now is this is very manual. And so what I want to do today is basically, there's this live streaming format called RTSP, which stands for like real-time streaming protocol. And you can imagine it as like YouTube or Twitch could use this to serve live streams, right? It basically lets a client come in and say, hey, I want to stream this file with these parameters, I want this bit rate, blah, 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 and then the server sends back the stream. And so we can sort of do this already with AV1, but what I want to do is actually create like a two-way communication channel. So yeah, if we just kind of jump into GIMP here, I'll kind of diagram this out. So basically, right now we have just a one-way communication stream, right? We have the AV1, right? And right now we just have our encoder, RAVE1, like that, right? And we can read that out with David, basically, or Davy1D. That's kind of the two projects I was showing you here with the encoder and the decoder. But it's not very useful to kind of run this one off and send video files. Basically, what I want is an encrypted communication stream. And so how are we going to do that, right? So we're assuming that the client, the kind of two parties that want to talk secretly, haven't been able to exchange anything before, right? And so what actually we can do is like a Diffie-Hellman key exchange, right? Which you guys are probably familiar with this already. There's this kind of classic diagram of basically what it lets you do is come up with a common secret by kind of sharing information over a public transport where you assume there's, someone watching, and basically using math. There's some nice like prime factoring and modulus stuff that basically makes sure this actually works until we have really good quantum computers. Or basically you can come up with this shared secret, which you can then use to encrypt your stuff with. So kind of the way this will look like with RTSP, right, is so we have our like client and we have our server, right? And so ideally we want to send this kind of both hidden, because it's steganography using the angles, and encrypted, so that even if you do, let's say you know this paper, right, and you find the angles and you know the parameters, it's encrypted, so you still won't be able to find that, and it's encrypted using this key sharing scheme, which we know to be secure, unless you have really good quantum computers, of course. But the problem is we have to figure out how to exchange basically some of these details here. Right, and so the way that's going to work is RTSP has a nice mechanism, of course, where the client comes along and says, hey, play, let's say play cats dot AV1, right? It's, there's setup and some more things here, but we can kind of ignore that for now. So the client will come along and say, hey, I want to play this file, and the server will come back and say, okay, cool, here's your bit stream, and it'll like stream it out to the client in real time. But actually the client, there's in RTSP land, there's these special parameters. Basically you can do like set param. And these are allowed to be sort of any arbitrary thing. So the server can support, special clients and special use cases, right? And so what I'm thinking is we can have a set param that's like basically using set param, the client can send their Diffie-Hellman, they're kind of mixed colors here. We'll get to the actual math in a second when we implement this. But basically the client can do like initial color, right? And then the server will start sending the video back. And in the first part of the video, there won't be actually the message. It'll be just the server's Diffie, basically the server's Diffie number. I forgot the variable name of this. There's some common variable names like E and M and N, whatever. But we'll get to there in a sec. And so this will kind of happen for this kind of the time axis down here, right, where the client initiates this. And so let's say the first couple thousand bytes will be just the server sending back this value. So let's say our client is Alice, right, and Bob is the server. Basically, the client can get the server's details, and then using their secret colors they generated, they can come up with a common secret, right? And then at a certain point in time where they both have to know when this is, the server will start sending inside this is all happening at least from the server side in the hidden bit stream. the server will start sending the actual encrypted comms. Encrypted. Right. And so the tough part is we're gonna have to basically know when to draw this line. So I'm thinking, we just assume the first 1,000 bits are going to be this detail, and the client, reads however many it needs to perform this operation, and then after that, we assume that the message starts at bit 1,000, let's say, right? Or we can do it 1024 or whatever. We'll have to find what works through testing. But yeah, sort of this is the high level goal, and so we're going to have to be basically running these commands automatically for both sides. And of course, ideally, I was hoping originally we could have this as like a proper RTSP server, right? So to anyone else, this is kind of the whole point of steganography, right? You want to actually hide in plain sight. So a normal person won't suspect you. And so if we could basically have a normal RTSP server that streams, gives you video when you ask for it normally when you don't expect it, that would be ideal. The problem is there isn't a good Rust one that supports AV1, right? So there's this one, which it's pretty solid, but it only supports H.264 and some audio stuff in MJPEG. So I looked into how annoying it would be to add AV1. It's pretty doable, but still kind of out of the scope for what we want to do today. We just kind of want to get this working. So basically what I want to do is instead, we'll pull up the spec here just to kind of get an idea of what's going on. So RTSP has, let's see. Yeah, it basically has these different commands you can give it. There should be a start. Yeah. So there's like setup, play, pause, turn on, kind of all the normal video streaming things you'd expect. So I was not going to implement anything near what the spec is. We're basically just going to implement set parameter and start, so that the client can kind of give their private details and then start the playback. But other than that, we're not going to look too much at RTSP. And then maybe sometime in the future, if this library gets support, we can actually make it a proper stake thing. But yeah, for now, this will be more of like a proof of concept, just to kind of show that we can have an encrypted hidden channel inside the video stream, which I think, to my knowledge, hasn't been done before with Diffie-Hellman, or you could sub in whatever key exchange you want. So yeah, so that's sort of the plan. We're gonna have to basically, am I in? Yeah, okay, we're in the shells here already. Ooh, I hope this won't take too long. Yeah, so anyway, we kind of have to think about how we want to make this work, right? Because there's the client and the server. And so sort of our server, if you could think of it, is kind of like this rave binary, right? Because it's the one that's doing, whoops, what the heck? Oh, no, we're fine. Yeah, basically this is the one that's actually encoding our secret into the stream, right? Which is the in that diagram we had before. That's sort of what the server's doing. So I'm thinking we basically take this binary and we just sort of modify it to suit our needs. And so we just basically want to copy, I think it's in bin, right? Rave, yeah, this guy. Yeah, we're just going to move it to rave server.rs, sure. And then we're just going to pop open the server, right? And so, yeah, actually, we can kind of step through this for a second. There should be, yeah, where's the command line stuff? Yeah, it's okay. It's in this common thing. But basically, this was kind of the CLI we were looking at before, and we were specifying the different parameters. So we, of course, have our actual parameters, which, so what do these actually do, right? So the paper sort of mentions, yeah, these kind of offset padding pairs. And so these are sort of attributes you can mess with, or where did that diagram go? Yeah, so basically the offset tells you which bit, where we inject the first bit, basically, right? So with this thing, you can see with these source values, with offset 0, we injected the first one here, offset 2, it comes in x2, right? And then padding is just how many bits in between you do, right? And so you can mess with these parameters, and both sides have to agree on it. Right now, I'm just doing offset 0, padding 0 to make it simple, but we can kind of mess with that in the future, maybe. And then the actual data we want to run, which, of course, this will actually be changing over time, right? Because we kind of want to do this initial handshake and then send the actual hidden data. So we're going to have to modify this a little bit. And then there's kind of the normal AV1 parameters for like the bit rate, noise, and things like that, right? So a lot of the stuff we won't have to touch, but we now have a copy of this file that we can start messing with. And yeah, so basically the plan is, so yeah, we basically have to create fake RTSP server, and basically this will be, for now we can just make it like a TCP socket with some kind of like, you know, binary format where like we read a single byte, and like let's say 0 is the set param command for and then we can have another one that's like 1 is basically with a string path, right? So this is kind of mocking the RTSP one, which has like, if I do match case here, we should be able to find it. Oh, here we go. Yeah, method definitions. So play, for example, right? Yeah, so play takes kind of a path to the actual audio. And so we're going to want kind of a simple version of this where it's just a string to kind of for the server to choose which file it's providing. We don't have to actually use this. Actually, no, for simplicity, we won't. We'll ditch the path. We'll just take a 1 for start playback, and then we'll have, let's say 2 will be like pause. Okay, and sort of the flow of what's going to happen, right, is so client so the client generates the secret, and then this will be sort of the other steps we have to do. So there's sort of the encoder part of it and the decoder part of it, right? And this can be handle and the decryption, right? So the client basically comes along and generates their Diffie-Hellman secret, like from this image. We'll get to the actual math in a second. Things we're also going to have to agree on a common paint to start, which is usually the server's public key. I'm thinking for now we just hard code this for simplicity, but there's, you know, other methods we can do in the future. We can have like another RTSP sort of like fake endpoint where they can just request this information, right? Or some other hidden, you know, mechanism for exchanging this. And so yeah, the client generates the secret, right? And then the client calls set. Then next client TCP connection to the server, right? Client calls with what should we call this? Yeah, so we're just going to assume that this we'll just call this the mixture, right? Which is kind of these mixed values that need to be exchanged in order to find the common secret, right? Okay, so now the server has that. So in theory, the server should now be able to. So now, yeah, basically this is going to be on the server side. So then the server generates. It's going to generate its own secret, and server. Or here, we'll have this kind of as like a. Right, this is kind of from the client's perspective because this is kind of happening asynchronously. So then, yeah, the client calls set param. So now the server is waiting to request to start playback, right? So then the client calls. Yeah, and I'm referring to this as calling it, but really this is just sending a specific command. But you could think of it like conceptually as a like a weird gRPC, even though we're just sending like a single byte, like a control byte that tells the server what to do. So the client calls start playback, and then server uses up to first 1,000 bits, right, to share its mixture right? So then on the client, so the client receives the server mixture. Over here, it is another step. Okay, and then as the server is sending this, the server has already received, basically we enforce that they have to call set param before they start playback. So then at this point, we actually have enough. Here, we'll make this C here. Server. So the server is going to compute that now same shared secret as well. The client will do it down here once they receive the server's mixture in the first 1,000 bits. And then after a client starts and so this might get a little tough with the bit rate of the server, right? Because actually no, never mind, because at this point in time we already have the shared secret, so we can start encrypting as soon as this goes. And so basically the client starts playback, and then after after reads actual right, so basically the client or the server is asynchronously streaming this video to the client, right? And we're gonna have to modify that because this binary doesn't include this already. And so after that first 1,000 bits, we're gonna have to actually read the file and encrypt it, right? Because right now in the CLI thing, right, we're only taking in a string, right, of the thing we want to hide. This should really be a file, and we basically want to stream it out. Okay, so let's go back here. So we're going to tackle this first because we're sort of in this project already. Then also for the encoder, this is going to be send and then the encrypted payload file after, right? And then the decoder is going to be sort of the opposite, where actually, the decoder is sort of going to have to be, which is C, unfortunately. So we might have to actually do this part of this in C, or maybe we can do FFI, or who knows, we'll see. But as part of this project, we basically need to and then decrypt, and so we can basically print out this this hidden file over time, right? Cool. So let's get started on this guy. So this server, this should have an FN main. Yep. And so basically, there's going to be some concurrency here. We'll probably just have some kind of like global mutex to keep it simple, because if you think about it, actually the bit rate of this is pretty low. Like when we were running this guy, it doesn't need to be very high, even though our carrier is low. And so so basically so if we come back to main here, we're gonna do like, is my intel okay? Good, it is working. Start. It's not really RTSP, so I don't want to call it that, but it's probably the most clear name I can come with. Start RTSP task, right? And so this is going to be the thing that owns the TCP server. Do we have? Oops. I think dev should allow us to use it from the binary, right? So let's go back here, and it's going to be anyhow result. This this is just going to spawn the thread that owns the socket. It's not TCP stream. TCP listener, that's right. And we'll make this nicer later. And for now, we'll just unwrap. I know we're returning a result here, but this is going to make it more obvious if we run into errors. And let's see. I wonder why it looks like my IntelliSense isn't working. That's a bit annoying. Oh, maybe I have to add it as... Do they explicitly declare the... Okay, they do. Yes. That is not it. I was literally just running it here. Hold on. Yeah. Okay. All right. Yeah, so basically we want to run instead. There we go. Okay. Yes, gonna import this guy. Import this stuff too. Thread. We'll just add it normally, whatever. Oh, and that doesn't need to be here. Cool. And so, in our little plan here, actually, let's move this closer to our main. This is where everything's happening. Yep. So we basically want to handle these different bits, right? So this is going to take an arbitrary number of things. Actually, so we want to handle... Do you want to handle multiple clients? I'm going to say no, because it'll make it simpler. We'll just assume we want to do one at a time. So we're going to basically bind the socket. We're going to have an outer loop and an inner loop for each client. Actually, no, we'll just exit when we're done. Yeah, so if the client disconnects, we'll just exit the whole program. That seems reasonable. So actually, we should wrap this in a buff read. Buff reader new. Oh, right, we have to accept the client first. Accept. Right. Whoops. Or do we have logging macros in this? I think we do, right? Okay, nice. Oh, it's a log crate, sweet. Okay. And we'll just print out the address when they join, right? Okay, and then now we want to actually do stuff with the client. And so the state's pretty simple. We're basically going to wait for set param command. So actually we don't need this loop. And we can... Actually, no, we don't need to, but that's fine. Yeah, so basically just going to have an array of 1, and we're going to do client dot read exact. This is immutable, right? Actually, this doesn't need to, because we're just accepting it. Actually, is accept... Oh, yeah, I guess you could share it between threads. Interesting. Yeah, so we read the single command. And for now, we're just going to assert that the command, or we're going to do assert. This should be 0 for set param. Set param Actually, we will do it like this, so we don't have to print the array stuff. Yeah, so we basically got that. Now we want to read the size of their secret. So I'm thinking we basically, this can be like a U16. This will be param length. So we're going to read that exact. We can just use the same variable name, that's fine, equals U16. We're going to do from LE bytes. These are just assume it's little Indian art, always param length. And then now we want to actually read in param length as U size, so we'll just allocate a buffer for that, right? And then we'll do basically the same thing. And it has to be mutable, right? Yep. Oops, and we will just print out. Actually, no, we'll just print the bytes, it's fine. Okay, so yes, printing out this parameter. Then the next step will be call set param. Okay, now we want to do some of the Diffie-Hellman stuff. Hopefully there's some code we can just copy. That kind of lets you. Yeah, it'd be nice if there was a trait, and so we could kind of abstract this and let people like sub in whatever thing they want. And then public key from. Okay. Yeah, so we're basically gonna have to hard code this. Let me think. Let me think. And they both call Diffie-Hellman, and then they're the same. Okay. So actually, maybe we don't need. Oh, I think Diffie-Hellman establishes these. Yeah, these common colors, and it looks like this crate. We literally just do this twice and then call it, and it'll be the same, right? So this will make it nice and easy. I like this crate. Okay. Yeah, so kind of looking at our plan here, right? So when they call set param, we generate our secret, compute the shared one with the client's param, and then basically wait for it to start. So yeah, once we get this param, this doesn't need to be random. There's probably a feature flag for this. Actually, we don't need it to be random. Yeah, it's short-lived. Okay, yeah, this is fine. It's just 32 bytes. Oh, we need get random. It's going to be server public, right? And then we do Diffie-Hellman with Bob's public. I bet the types make this really nice. Okay, so then we just need to construct a public key. And this, is there another way to do this with bytes easily, I wonder? Let's look at the docs. So yeah, we basically want to construct a public key. Two bytes. Is there like a from? Oh, perfect. Yep. So we just need 32 bytes, and then we can make it from. So actually, we'll enforce that this param has to be 32 bytes. That'll make things a little bit easier. It kind of. Actually, no. We'll keep the API flexible, but we'll only use the first 32 bytes. And 30. Oops, caps lock 32. So it's going to be greater. It's kind of funny because we're saying like, oh, this is set param when really it's, oh, excuse me, when really it's it's the first part of this key exchange. So I almost don't want to have the error message like, oh, we're doing Diffie-Hellman, guys. Like the Diffie-Hellman size is at least 32. So do client equals. Oh, whoops, no. So we want this to be a vex still. Sorry. Right back to where we were. There we go. And this will make this info as well, right? And so this is going to be public. And then we'll copy from. Yeah, so we made sure it's at least 32. And so we'll just grab the first 32 bytes and copy it into here. And now we'll actually do this all here. Public key from client public. Right. So now we have the client's public, and then now we have this, right? And that is our shared secret, which we can then, I think we usually just pull out the bytes and then use that. So then we're going to want to do some AES stuff. I think ring is the most popular one right now. Yeah, I wonder which crate. This thread is a little bit old, though. Ring. Yeah, we can do the pure Rust one. This is kind of a research thing anyway, so... Oh. Okay, we'll just use ring. That's fine. Ring. I have no idea how to use this crate. I've never used it before. They better have examples, right? Okay, ring probably also has our public key stuff, but that's fine. Cha-cha. There has to be AES in here, right? Oh, we're also probably going to want to... that's a little unfortunate. We might have to think about the different modes, like if we want to do cipher blockchaining or whatever. Yeah. We'll get to that later, though. Actually, screw it. Let's just use the AES crate. These ring, this seems a little complicated to use. Oh, this is raw blocks. Okay, maybe we shouldn't use it then. Rust ring with, what's it called? Yeah, we don't really want to do authentication. We just want to use our shared key to do a lot of encryption. Okay, I guess these aren't stream. Yeah, authenticity would be something interesting to consider here, but it's definitely out of scope for today. So we're just gonna throw it in AES and hope for the best. Okay. Oh, nice. Oh, we don't want to do this tag business though. Hold on. I wonder, could we just use cha-cha poly? That's probably good enough. Yeah, really, we're not trying to actually be secure here. This is more like a proof of concept showing that this could actually work. Let's see this guy. Yeah, we don't want associated data. Yeah, we can just use cha-cha poly. That's fine. Docs. Let's see. We don't want the nonce though. Yeah, we won't worry about this for now. Yeah, we don't want to use poly. Okay, so this actually should be fine. This kind of, we want just this base cha-cha 20. So let's see what we can do here. I'm in doubt. Yeah, okay. Oh, interesting. That might be useful. Yeah, so this is good because we want streaming messages. So yeah, this should be useful. The thing is though, we basically want to stick this into, once we have this done, we want to stick this into our global state somewhere. So we're going to be really dirty and have a the problem is this is going to have to be probably in the main crate that we're modifying, since we're going to have to access this in, yeah, inside where we do the modification. Yeah, so this, what's it called? This file. Oh. Create hidden information counter, yeah. So this file, stag, or I guess it's in the stag folder, mod.rs, yeah. This is the actual state for what I was showing you guys before when we're actually encoding this. So this is likely where we want to put this. So if we go back to the server here, we construct this down here. yeah, so this kind of takes the offset, and then this does the logic for actually encoding the angle, right? Injecting it, modifying this stuff, and shifting that around to the next thing. And basically, we're gonna want to modify this once we get the finalized thing. So actually, what we can do is we can have a channel here. We'll just use the normal standard one. No need to include crossbeam here, even though this is kind of like a one-off channel. Can we do bounded channel? Sync bounded channel, yeah, because we only want one thing. And then we'll pass the TX into here. Sender, we'll import this guy. And this is going to be, yeah, I think we'll literally just send the shared secret. And then in the future, we're going to want, yeah, so we calculate this. And this should only happen once, so we can basically try send and unwrap here. Shared secret. Is there no... Do they only have blocking send? I'm not super familiar with the standard channels. Oh. Okay, that's fine. Well, yeah, we'll panic anyway, so that's alright. So we send it, and then... yeah, ideally we want like a... I think there's some crate that's like Rust. I forgot what it's called. There's some crate that does this. Oh, yeah, maybe it's probably one of these. Mlock. Yeah, I'm really looking for kind of just a wrapper type that on drop nulls out the bytes of whatever is in there. Zero eyes. Do they have like a zero eyes on drop? Yeah, okay, this is perfect. Yeah, does deref? Yeah, and on drop it just zeroize it. Okay. And this trait, hopefully this is automatically implemented for this crate. Ah, very nice. Okay. Cool. Yeah, so we'll add this guy. Oops, this guy. Right. And we'll change this type to be zeroing. Okay, whatever. We'll just do the whole type. Oops. Yeah, okay, so we do this. We have to, I think this has into. Yep, okay, we don't need a to do. That'll null it on drop, that's good. I hope though, that gets a little annoying when it gets moved, because it's going to get moved in and out of the channel, and then who knows if that's going to get zeroized, right? Because it might only be actually dropped once. But, oh well, you know. Oh, I guess this has to be... Wait, when did they change that? I don't remember since 1.0. Oh, I guess yeah, I never use the standard channels, so... what are you crying about? Oh, we have to move. Yep. Cool. So that should send, and we have to send the server's public key. Yes. Server public. And so this will be really, let's make a struct for this actually. Public key, right? So we can just pass this guy. Should be able to move into server public. Oh. Okay, we're not using ring anymore. That's fine. I guess we just auto-imported the wrong thing. That's fine. We'll move this guy to here. All right. Okay, so actually, the interesting thing, so as part of this task, because this is sort of the networking task, right? If we go back to our diagram, then we have to wait. So we've kind of done this stuff, but we want to wait until the client issues playback, right? But actually, we can be sneaky and basically block this whole thread on receiving this, right? And so we're going to do let data equals rx dot receive. All right, should always give us data. Oh, and we'll want to derive debug on this guy. Actually, I don't know. Yeah, because we don't want to dump out our private key. But yeah, we do want to print. We'll just print out like the server's public key, right? That's fine. Yeah, and so what we can do is, technically at this point here, we could send the data, because we're here, we already have the shared secret, but we want to wait for the client to start playback anyway, and so we can literally just have more blocking code that does networking stuff, and then we send this at the end once the client actually requests playback. And for example, if this was a real RTSP server, if the client doesn't actually do this like set param business, we would just stream them the video normally, right? Because we're kind of hiding in plain sight and we behave normally if people don't actually know the secret handshake. So yeah, this is gonna look pretty similar. Basically just gonna read another param, and then we're gonna assert that this is 1. Client didn't send after expected 1, right? Okay, so then once the client sends that, then we're good to go, right? Then we have everything we need. We have our secret already good to go, and then we can construct, what is it? Yeah, in the stake thing, we're basically going to instruct one of these for the first 1,000 bits, using to transmit our own public key, and then after that we're actually going to do the encryption, right? And actually we can change this to be, instead of 1,000 bits, so this is 32 times 8. Okay, it'll just be 256. because that's how big our public key is. Let's make it nice and easy. Cool. So actually I'm thinking we probably want to refactor this to have all the logic live here, right? Because we have these kind of pub functions, and we want to just kind of extract this one at a time. So encrypted, just call this encrypted hic. And so we're going to have basically one of these for this is going to be, we're going to have one of these for sending the pub key, right? And then one of these for the data. Actually, let's change the name of this to be, just to make the renaming easier. We're actually going to call this, right? Because basically the client code uses this to inject the angles and calls these functions as it's encoding. And so this is going to be 2. Oh, and that's it. Okay. And basically we have to implement, can't be recursive, that's fine. Yeah, so if we try to build this now, we should get a bunch of errors about how these methods aren't found, right? And so basically what we're going to have to do is take all of these pub methods. We'll do new later, since that's going to be a little more complicated. We just get, this code is, I really don't like this code. It's very confusing. I sort of just took this from the paper, but basically we're gonna have to figure out, so if we haven't finished transmitting the public key, we want to do that first, and then once that's fully transmitted, then we're gonna transmit this basically. So we're gonna just have each of these functions will just dispatch to the right thing. We just have to know is done. Yeah, okay. So yeah, if basically we're just gonna branch on it is done. So if pub key dot is done. So if it's not done, we're gonna do dot pub key right, and all the functions are basically gonna look something like this. So stop pre-encoding, stop pre-encoding, start final, stop final, thing is though, we're gonna have to make sure we switch over cleanly from one to the other. Whoops, these need to go away. And for now, we'll just put debug around all of these, just because I want to make sure that we don't switch from one to the other in the middle of injecting an angle when we shouldn't. So this should fix most of the errors. A new will still have to fix. This is annoying. We almost want like a trait for this. Yeah, so we're gonna do, this is gonna take, so this new takes, yeah, we'll just have, I don't want this to be public though. We'll just call this like inner hic. And we'll call this, we'll just make this hic as well. Whoops. Oh, nice. That actually worked with the errors. Good stuff, REST format. Or I guess REST analyzer. And yeah, we're just going to have this take in. Let me see here. Yeah, we're literally just going to take in this. And this is going to be, and just data, we can actually keep the same API to make this easier for like the normal use case, so we don't break that. And so we're basically going to default construct this guy, inner, with an empty and then 0. I guess this would be none, and then data. Oops, data will be steps to skip offset. Yeah, I don't like how they're not consistent with the naming here, right? This is padding. Oh, that's fine, I won't change it now. But in the paper, they use different names for it, which gets a little bit annoying. But anyway. Okay, so we got to write all of these so that it works out. And then, yeah, we're going to have to do, go to the server, find out where this is failing. And so actually, let's change the CLI now. Yeah, because I want to basically read this from a file so that eventually we can have like a fully streamed kind of secret communication channel, so that way you don't have to know all the data up front. That's fine. For now, we can actually just keep it as a string though, keep the same API. Let me think. We will have to make this public key, right? So up here we should have established run. Okay, run is gonna have to take. What does main even do then? Oh, it just calls run. Oh, it just basically prints the error. So yeah, actually let's just do this as part of a run. That'll make it a little bit easier. Init logger config if run. Okay. So yeah, we parse the CLI. We'll parse the CLI first because if that fails, we want to do that. We'll do this task stuff. So we have our data, right? So then now we can, okay, yeah, we should be able to get the thing from this. Yeah, so hic new. If it's none, we're gonna do just data, right? So we kind of keep this. And this, okay, it's adding a null byte. Yeah, right, because we look for that. Actually, we're going to have to change that logic slightly to only look for that when we're transmitting data and not the key, because it's unlikely, but the random public key might contain 8 zeros in a row that are byte aligned. So we just have to be aware of that. Yeah, so we read. Yeah, so I guess we do the file IO in another step. Or no, it's specified explicitly. Whoops. So yeah, we read the bytes. We push this. So this is going to be data inner hic. We're going to have to use this. Actually, it's literally just going to be this guy. Pub key, right? Yeah, we use the same config for this, except this is going to be, there's too many datas. So this is going to be payload. Yeah, actually, I like payload. It's just a much better name. Data is going to be, right? So, and this is going to be data dot pub key. So this is going to need encryption, right? So pub, actually we should do this on initialization, right? So it's going to be almost the same, except we'll kind of encrypt the whole thing in place and then send it, because we have the whole file already. So this is going to take key, which is going to be this shared secret business. And yeah, we can just do the encryption in here to make it simple. Steps to skip, offset. Yeah, and we'll make data mutable so we can compress it in place. Maybe there's an API for that with this guy. Let's see. Cha-cha 20. Yeah, maybe we should just use the cipher thing. Traits. Okay. I guess it doesn't say how you actually construct this. The traits let you operate on it. In place, okay. Let's see. Yeah, so let's add this crate. And then this will just take in some kind of stream cipher, right? I wonder though, do they implement, I wish there was some kind of like extremely generic trait that's just like algorithm, right? Because I don't want to have to, because I guess the issue is adding in like doing padding for block ciphers if you don't have enough data. With a stream cipher you can always send it, but if you could specify how to do the padding, right, in theory you could just have a trait that's like encrypt bit, right, and it'll just dispatch to either one of these. But that's all right, we won't worry about that for now. Okay, so we have our cipher, which is going to be some kind of stream cipher. So we're just going to do, whoops, mutable goes here. And we want to use, what's it called? We just had it. Stream cipher. Okay. Yeah, we want to do apply a key stream. Oh, actually, we'll just assume that the caller already created the cipher with the right key. Actually, no. If we're doing that on the outside, we'll just do the encryption on the outside also. So, data dot shared secret as bytes, right? And then so we need to construct this guy somehow. our nonce. Yeah, we don't care about the nonce, whatever. Yeah, so the key is going to be this. And we'll probably have to reference it as a slice, right? Did we add this crate? No, I don't think we did. All right. So try 20. We add the nonce. Ooh, interesting. Ah, okay. Nice. Yeah, so it looks like they do have some amount of wrappers for this. And we'll import this guy. And new, this probably has to be, I think auto deref might help us here. Okay, we had this to be in scope, I see. Yeah, let's just try a slice. Oh, it has to be generic array. Okay, generic array should be able to deal with this, though, right? Okay, we don't even need to reference it. Nice. So you get the cipher, we have the nonce. We'll do, what was it called? Yeah, apply keystream. The whole thing, yep. To and this is going to be the server public, right? But it has to be a vec. As bytes. Yeah, we'll just collect this. Actually, no. The type elision should work for this, right? Payload is still a hic. Actually, we have to do this after we encrypt this. Right, and then this should be mutable. Yep. Oh, so yeah, that's interesting. I guess as we go bit by bit, we have to decrypt one byte at a time and then look for that null byte when we're handling the stream ending. Do this. Oh, iter copy, right? Okay. Data. This is going to be pub key payload. Okay. So now this should, in theory, this should work. Let me write some test code. I'm curious. No, actually, we can't have test code because this is all dynamic. The keys are dynamically generated. Yeah, I wonder though for when we generate the keys here. Yeah, if we just do like all zeros or something for our Diffie-Hellman. Let me think about how to test this, right? So Oh, okay. No, this isn't actually Diffie-Hellman. This is just a regular curve. I guess there's no way to test this in isolation easily. So I'm thinking, yeah, we can just do like a basic netcat test, but then I want to crack on. So yeah, I want to run this. It should wait. We'll say, oops. Oh, we need the 0 here. Okay. And say yes, overwrite. Oops, and we also want to run this with logging. Oh, except we're not writing it to a file. This time we're streaming it. Right, because we can't write it to a file. This has to be real time. And we're not getting our log. That's interesting. What does this do? Oh, it's a different variable. Okay. Yeah, we can just disable this. We're always going to want to overwrite it. Actually, no. Hopefully this muxer... Okay, it's a din right. Perfect. Okay. So yeah, we can just construct the thing we want. And do we get logging now? Nope. That's unfortunate. Did I typo this big time? RAV1E log filter string, right? Info. Yeah, this should work, I think. That's fine. We can just use printline for now. Guarantee that it'll work. Yeah, for now I want to do some kind of minimal test. So 0.0.1. Yes. Waiting for client to connect. Okay. So yeah, we're going to connect to netcat. We bind to 6969. And so we're going to have to, this is going to be a little bit annoying to encode. We're going to have to do some binary stuff, right? Because we're basically going to send, so yeah, if I send a 1, this should panic. Yep, because we didn't get the right thing. Yeah, we're gonna have to just echo some like bash escape sequences. Okay, perfect. Yep, so we can just do this. So yeah, run this guy, yes. Oops. Okay, yeah, and so then if the client disconnects, the read fails, and then the TX fails, and so that panics. So that's good. That's what we expect. And so we're gonna want to send it. So 0x00 for this length here, and then if I send these, it should panic because the param length is too short. Whoops. Oh. At least 32 bytes. Okay, that appeared to work. Yeah, let me do this with an actual thing now. Yep, okay, so it fills immediately, it's too short. But if I go in here and make, so this is little Indian, so if I make this guy 32 would be 20, and then we just have like a bunch of crap, right? Yes. Nice. Okay, now it's expecting a 1. Okay, so if we actually count 32 32 bytes. So we have our length 1 2 1 2. Now we need a 0 1 for start. Yes. Okay. Yeah, that looks like it looks like it's coding this stuff now. That's good. Yeah, I want to see what these bits look like, right? So yeah, it's sending the pub key. Where did it panic? Self.pre-encoding. Interesting. Okay, this is exactly what I was afraid of. Oh, because we say we're done. Okay, what's the last function that gets called here? Like, what's kind of the life cycle of these function calls, right? That's what I want to know. So, because basically the issue is we get this panic because after, basically there's a certain order that these are called, right? Like start pre-encoding, stop pre-encoding. I don't know what it exactly is, right? But basically these get called, and then we call inject angle in between a call to like start pre-encoding and stop pre-encoding. The problem is though, in inject angle, it'll consume some of the bytes, right? And then if we're done, it's going to increment these positions. And then in the end, what's going to happen is that is done will end up returning true because we've injected the last angle. However, we're going to call the wrong thing, right? Because we basically have this mismatch. So we're going to need some other way of kind of being smarter about this. And for that, I'm going to have to figure out like the life cycle of this, right? So if we come back up here, this is good though. It looks like it generated the secret. It sent the whole, or pretty much all the public key, and then we hit that panic. So this is looking really good actually. And there should be 256 bits being injected here if I'm not mistaken. Let's try to find the top. This might be a while. Oh, it's this might be an infinite loop actually. Yeah, that's all the data we have. Okay. So what's a good way to solve this? So we're gonna say on pub key, right? And this is gonna be true by default. And then if it's just data, it's gonna be false, right? So we go directly to payload. And then instead of doing this, if we're going to check for self dot on pub key. And then we're going to need some logic to basically modify this when we're actually done. And we'll get rid of these debugs also. We're going to escape. Can we do parentheses like that? Okay, we're just going to delete it. Yep. Okay. So this should panic now, right? Because this is never going to change. Like if it's not enabled, if we're done. Okay. Yes, waiting. Okay, go. Okay, so this is spamming, unfortunately. Yeah, we might not be able to see this at all. There's a panic somewhere else, though. We might be able to. We should probably set Rust abort on panic, right? So that way we don't. Because now that we have multiple threads going, and I think we're running this in release mode, right? Yeah. Okay. Yeah. So we'll just dump this in here, changing all kinds of stuff, but that's all right. Why are you crying? Okay, it really doesn't like that. Are we in the middle of something? Package, features. What? That's odd. Let's just try adding it at the end of the file, maybe. Oh. Yeah, okay, that's why. Alright, that's probably gonna have to recompile. That's alright. Actually, while it's doing that, I'm gonna grab a drink real quick. I'll be right back. All right, no desktop audio, sweet. An hour 31, that's not bad at all. All right, I'm back. So yes, overwrite and run. Oh, we're starting the wrong thing. do you mean got 1 0? Huh? Assert. Oh, do we assert after we read this? Let's just see the line this is on. 398. Oh. Oh, it's because it's a loop. Yes. So actually we want to just end this task. Yeah, because of course it's reading some random crap after. And then after this we're going to return okay. Like that. Yep. And so I guess technically this doesn't need to be a separate thread. I thought we'd have to do stuff in parallel with it, but I guess this kind of run thing makes it easier, where you can literally just do it here. So we should receive the data, and then we'll just do join, right, like that. Unwrap dot. Task failed, right? Cool. So yeah, we have this should be working now. If we run it. Oops. Yes. Echo. Okay. Die. Okay. That I'm gonna add a sleep. Alright, we're just gonna sleep for like 10, just to slow it down so we're not log spamming as much. Okay, looks like it's encoding. Yeah. Injecting, very slowly injecting. And I want to see what happens when this turns to true. Okay. Die. Okay. So yeah, that wasn't as much log spam, that's good. Oh, yeah, that was Control C. Yeah, so I actually want to pop this up in Vim and just do like a quick sanity check. I'm going to be logging too much. I might not be able to get all the values here because my terminal might not store all this, but we'll try and see. It's very slow going. Actually, this is gonna be too much log. Okay, so actually what we'll do, we'll just assert that it's not done, right? So we panic whenever this finishes, and then we don't need to sleep anymore. Yes. Send. Okay. Yep. Okay. So panic where we expected. It skips, yeah, so the 6 I can't modify, it has to skip that, of course. And if I look at this, we just pull this up in like here, right? We just put this in like a temporary thing. Injected value is greater than 99. The thing is, there should be exactly 256 of these, right? Yeah, so actually, if we just delete all of the ones we skipped, just say, yeah, and then if we do in Vim, if we do visual mode, right, we can go back to the top. Look at that, yeah, so we injected 256 angles cleanly. And so, yeah, it looks like when it's done, okay, so now we should be able to test this. So if the first one is done, and self dot on pub key. So if it's actually done, but we think we're still on it, we're just going to set this to false. And if start pre-encoding is the first thing that gets called, so we modify this to false. So now all of these branches will go to payload. And so in theory, I should be able to dump. Yeah, so let's run this. Okay, so this is going to be with hello YouTube. And this should be, actually I want to just do some testing here. We'll use a fixed key so we can verify this is actually working. So instead of random NFUL secret, new random, there should be, okay, this is pub. So yeah, we should be able to generate this. So let okay, this is gonna be the worst encryption ever. We're literally using 0. I have to use new, I guess. No, maybe not. This is pub. Oh, it's pub crate. No. How do we actually generate this though? So it is from. This is shared secret. Okay. We could make our own RNG that returns the thing we want. There also might be another from implementation. Reusable secret. Yeah, they try to make this hard to abuse with types. Okay, static secret looks like it implements it too. Yeah, I think we can just use static secret. Pub key. What do you mean it's not here? Is this not pub or something? Oh, it needs the feature. Oh, this is the X thing. We'll just do it in cargo.toml. What is it? X. That's really annoying. Okay, come on. There we go. Bring me back. Yes, okay. There we go, finally. Okay. Right, and we just gotta import this guy. Oh, it is from. Okay, sweet. This is totally insecure, but who cares? Static secret. Okay, and this does the. Okay. Yep. Okay, so we're using the 0 key. So this should be easy to test for in some other feature code that we write. So we're using the fixed key. Yeah, let's see what happens. Let's just clean up. No, actually, we'll leave the imports because we need that still. Yes. Run. Okay. I'm just going to let this run here. So, this is skipping. Actually, hold on. Let me do this one more time, actually. So, stag. So when we set this, we're going to do so whenever we switch, we know that. Yes. Okay, it looks like we sent all of it too. Yeah, so, yep, it looks like we switched cleanly. So this will be interesting. These bits should be our encrypted message. So if we dump this file using the decoder script, yeah, let's actually check out what this public key is. So yeah, this public key is more or less random from our, so our client's public key is all A's. Our secret key is all zeros. We generate our public key from that, and then we use our private key of ours, all zeros, and this key to generate the encryption key. This is the server's public key here, and then as soon as we switch over, this is the encrypted hello YouTube phrase. So I'm just gonna let this run here. We should actually be able to dump this and just see. It should be unreadable garbage, right? Let's see. Yep. So yeah, it's getting these final bytes that all make no sense. But this pub key, let's see if there's anything recognizable here. I mean, we've proven out that the base transit mechanism works. 47, 229, 125. Yep, okay, so there's our key getting transmitted. These bits, okay, so it got 373 injected. Wonder why it's not an even number. Oh, I guess because it goes until it randomly gets everything, and then it's, yep, okay. So yeah, this guy actually seems to work. I'm fairly pleased with this. So let's go ahead and commit this. What is in this? Okay, for the optimizations, yeah. So we're going to say decoder works, right? Yeah, and so now we actually have this test file we can use. And so, yeah, I'm thinking where we go from here. Oh, I wish I saved that old image from before. Anyway, okay, so we should have this side done, right? So basically everything, this is our server here on the right. This is set param, right? And then this is the server's pub key. And then sometime later, after that gets transmitted, this is going to be encrypted data, right? This is the client. Unfortunately, this client is really stupid right now. It just basically prints out, right? It tries to print out. This is decimal, which obviously isn't going to work, and we want some way to do this automatically, right? So what I'm thinking, because we already sort of have this decoder working, and because we're using these Rust crates that make it easier, I'm thinking we almost have this be two parts, right? So the project we're running now for the decoder is this, what's it called? DAV1D, right? And this is our special one, right? That basically reads angles. My handwriting is terrible with a mouse. Right, and so right now it's dumping it out, which isn't useful to us. But what I'm thinking is basically we make like a Rust wrapper, right? Not a Rust wrapper, no, with a W, right? And so this wrapper is basically going to call into this and basically give it, I'm thinking probably a path for a Unix socket. And then so as it reads out the bits, the injected bits, right, it's going to send it back to the Rust program, which for the first bit will allow us to get the pub key, right? But then eventually, after that first 256, that's going to actually be the data, right? The encrypted data. And so we kind of need this Rust program to control everything, right? We're still going to use this guy as kind of the like meat and bones that's actually going to pull the bits out of it. But then we actually need this program, right, to hit up the server, right, make that TCP connection, send like, you know, that opcode 0 for set param, then it's going to have to set the 1 for streaming, right, and then it's going to have to then, oh, actually we do have to modify the server to send the AV1 AV1 video, right? That's going to have to be a separate thing. Actually, we'll do that next on the server. Then we have to write this Rust program that's going to basically read the TCP, pass it into this guy. So actually, we need 2 Unix sockets, right? We need one where it can accept the AV1 stream, which actually maybe we can reuse this stream already, right? Because right now the server's receiving this only, but maybe we can actually have the server. Yeah, actually we'll do that. Yep. So this, it's kind of this communication channel here, right, where we have the set parameter. This instead will be the AV1. We'll send it back on that same TCP socket. So basically, the Rust wrapper will own the TCP socket. It'll set up this stuff, right, do the set parameter, generate its keys, request the stream to start, and then it'll start reading the TCP stream. It's going to pass that into this decoder, and when we run the decoder, we're going to give it a Unix, just like a path to Unix socket, and then it's going to give these bits back to the Rust parser, and then basically we're going to actually make sense of them, right? So inside here, we just receive the raw bits, we get the pub key, then we'll do basically this the encryption stuff to find that shared secret, and then once we start getting the data bits, we can decrypt them as they come, right? And then of course we'll stop when we get all no bytes. So yeah, that's the plan. We'll implement. Yeah, we'll switch over the encoder to start sending over TCP now. Actually, this will be easy to test because it'll start spamming our console here. Okay, so let's go back to this file, and then we have to find where it actually reads this. So in run, right, we get the CLI. Decoder new with limits. Okay, so this input is so it looks like as part of parsing, it actually creates this input output. Yep. And so we're gonna want to change this output to point to the TCP socket instead. And so actually, as part of this task, we should actually. So we have the listener. Maybe we should send this on the channel as well. The TCP stream, right? Because this buff reader, let me get rid of this, right? This buff reader, right? Once we accept a client, let me think about this. Okay, we bind. Yep. Things though, I'm not sure in TCP. Actually, let's test this. I'm pretty sure if the listener stops listening, you can continue the client streams that result from it, right? So I think as part of this data, we're just gonna have socket. There's just gonna be our TCP stream, right? And then down here, we're literally just gonna should be done. We will hold off on creating it until after we're done reading, right? And this socket is just gonna be client. Okay, so now we have the client socket on the main thread. I mean, arguably this doesn't need to be a separate task, but if we want to, future-proof this to have multiple concurrent clients or actually build this out to be real RTSP, it's gonna have to be multi-threaded, right? Cool. So now we have that socket. Parse CLI. We probably want to run this after, because this is gonna do the common stuff. Okay, input. Okay, so yeah, it looks like it'll do stdin here, except we want to change the output. This is create muxer. Okay, this is where it does the overriding stuff, or it opens dash. I wonder, is there a special case here? Yeah, okay, it'll create the file, otherwise. Yeah, so it's either stdio or it actually reads from the file. I want to try to modify this in the least intrusive way. So, okay, so after we'll hold off on parsing this until after we get the data, right? And we're just gonna have this be this is gonna be the DIN right? So I guess it's good because we don't actually need to read from the socket after this. We're only gonna be writing the AV1 data. So this can be data.socket. This is gonna be box DIN IO right? And now we can put this here. And this is basically going to be just the override flag. And yeah, we're just going to change this guy. Hic. We'll make this just data so it still works. Same here. Just data. And then also this is going to be none, right? Because we don't want to override. Oops, this needs to be an option. And then here we create the muxer. Yep, hidden string. Where did we create output? Input, output, create muxer. Okay. Output override. And this has to be an option as well, right? Unused. And then here, instead of matching on this, muxer open. And this should take a boxed in path. There better be boxed in, right? Check file, open. We'll just add a new function here. And so this is literally just this, right? Oh, it has to be sent. Okay, we're gonna have to add that bound as well. It's gonna just do output. Why are you crying? Muxer, boxed in, right, and send. Oh, duh. Okay. So we have this created. We're gonna have to add this send bound, right? And send. This needs it as well. And let's see how we're doing. Okay. Okay, and then yeah, we need it here as well, just to enforce that it is sent, which it should be. Right? Okay, this builds now. That's good. So yeah, actually this should work. So if we run this guy, so I'm thinking we run netcap and we'll just pipe it to. What's a good? And I'll just stick this guy here. H. Is this? No, that's the GUI thing. Is it literally just called dump? Okay. I wonder, I guess we could test this, right? If we remove, oh, hopefully it didn't touch it. Okay, so if we move, we're gonna want to save this back up, right? So now it should be gone. And now we're setting it to output to here, where that shouldn't exist. So if I run this, waiting for client to connect, it's injecting, it's running, okay. So now if I run, oh, it does create it, interesting. Are we running the right binary? Rave server, yep, okay. Interesting. Yes, create the output, parse CLI. Create muxer, right? Ah, we don't use it here. So we don't want to check this, so if let sum is the override, IVF muxer and out, right? And it's always okay, right? Because there's no errors with that. Oh. I guess, do these return? Oh, actually, it creates a DIN version of itself. Interesting. So yeah, we're going to want to use that same sort of coding style. Right, there's no CLI error for this. And new. Right, just to match, basically match the spec of these guys. Okay, so now we're going to remove this. Right, we still have the backup good. And it doesn't exist, right? So now if we run this, I'm interested how this will work. Okay. Okay, it looks like this is TCP buffering. Yeah, so it's totally sending us the bit stream now. That's good. Yeah, so we're going to want to basically connect to this now. So there's sort of two parts left. Let's go back to our plan. Okay, right. So we have this done with the play and stuff. The encoder, this is 256. And then sends the payload file after. Yep, in the stream. And we're sending that over TCP. Now, nice. My roommates just set the fire alarm off. That's good. So, man, they must be cooking steak or something. It smells really good, actually. It's not actually burning down, I promise. It's just this happens all the time. It's a false positive. So, we have this encoder working. The decoder, so there's two parts of this, right? So there's the David thing, which we're basically going to have to have raw, right? And then we're basically going to create connects to, okay, there we go, with the fire alarm. That basically connects to this fake, to the fake RTSP server, sends params, starts AV1, reads bits, right, and decrypts. So that's kind of the second part of that. This stuff is basically done with this plan. So yeah, let's hop into David and make it use the Unix socket. So yeah, these were the bits we had before, and this was what's this called? So where did I put this file? It's not source. Oh, this is build. I don't want to back out here. I think it was encode. Oh, no, it's a definitely decode.c because there's no encode. Okay, yeah, so we have, this is, if we look at the actual diff I have, that's probably some good context for you guys. Yeah, so this is just my fork of the repo, and I have this steg branch with a lot of commits, actually. That's weird. Yeah, basically, or here's the flake stuff. Yeah, basically the only thing we do is, this is the actual decoding code, right? You can see it's crazy, you know, video, there's all these parameters, there's context, right? This is the crazy stuff. We just go in surgically, whenever we decode the angle, we just call log angle. And so that's what we're using at the moment to write to this output file, right? It basically just prints out this. What did I do in this commit? Oh yeah, I'm just matching the format so the Python script can read it off, and it basically decodes the ASCII for us so we can check that. And so basically what we're going to want to do is have this function, instead of having this be a file, it's going to be a Unix socket. And so this, this load hidden message output file, this gets called every time, and we basically open it based on here. Instead, we're going to want to basically use that Unix socket. And I think Unix socket, we want something lossless. I just want to double check versus named pipes. Oh, interesting. Okay, we don't care about packetizing things because it's just bits. It almost makes me think maybe we should just use file descriptors and have it get passed through when we spawn the child. They're reliable. Okay. It's been a while since I've done this stuff, so let's take a look at an example. We can just hopefully copy paste. Path. I almost want to just use like a port, right? Because having a path, we almost want like a path in temp. Or maybe we just pass in a port number, because I want to use UDP, but it's technically, like, on localhost it should be reliable, but also you never know, and I don't want to have to run another TCP server on within the Rust wrapper. Let me think. Yeah, so this is probably what we want to do. The thing is, we're not going to be calling fork directly because we're going to do like the Rust standard process start. Yeah, we can't just reuse the file descriptor, because what if we have, I wonder if, does this ever write to standard error? Okay, it does all the time. That's annoying. Because yeah, I was thinking maybe we could have all the logging go to standard error and then have standard out just for the bits. That would make it quite simple, actually. Do we use... Actually, they might be really consistent with fprintf with this standard error. X hash, that's interesting. Oh, this just looks like special casing. I wonder if we run... let me get that command back. There we go. Yeah, so we'll hop, cd, yeah, log angle. Oh, it's backup. Yep. Okay, this is the same thing, right? Where we had, I think it started with like, yeah, 47,299. Yep. So this is our key for testing. Yeah, so fish. Yeah, so if all the logging happens to standard error, if we suppress this in fish, or if we pipe it, I forgot how to do piping in fish. I forgot the way to. Let's just do it in bash. Okay, so I think if we specify this, so st out to one file, st out to, so yeah, if we ignore this, so if we hop into, ooh, that is interesting. What? Never seen that before. That's weird. So yeah, if we run this guy, and we don't need to do our Python thing. It's weird. Oh, this is totally. Oh, I think because we piped. Yeah, we were printing binary, and so it probably messed up our terminal. Come on, baby. So we'll just cd into build, and then hopefully we should have that command again. Then we should be able to hop into bash and then just output just this to this file, and then we can verify, and then we'll be able to use standard error on its own, which will be really helpful. Yeah, so there we go. We got this. Oh, shoot. I just broke it again. Yep. Okay. Whoops. We got to do this again. Sorry, guys. So build bash. Yep. Okay, so we're going to run this except without the Python thing. And we're going to output the result of this to error.txt. Whoops. Okay, and then if we don't do this, this should work on its own. Whoops, I don't mean to format. Undo.
Are you busy?
Yeah, so yeah, okay, let's, whoops, we gotta redo this. Is this still? Okay, whoops, we gotta redo the whole terminal. This is in C, David, bash. I don't know why. I've never seen this before, guys. This is super weird. Maybe if we do this without this, this will work. Okay. Yeah. Okay. And outputting to error.txt. Okay. We're still printing. Whoops. Okay. Whatever. Build Ninja. And so if I run this without Ninja, it should print nothing and return. Okay, so that's good. So yeah, actually we can use standard out for printing. So instead of printing out this final byte, it shouldn't even be printf though. We're literally just gonna write stood out as this. Yeah, so we actually have to use this constant instead of the file, the libc file pointer, because this is the low level syscall. Right, I think it takes the pointer, which is going to be value, size of value, which should be 1, right? Because yeah, it's the buff and then the number. Okay, and so this should be writing the raw data. And this should be somewhat easy to test. So then, if we want to output it to a different file, data.bin, now that we're writing, So if we hex dump data.bin, that's not right. Oh, we didn't rebuild it. Cool. And so E5, this should be, if I remember our things right, E5 should be 229. Okay, sweet. Yeah, so that appears to work. Now we can write the wrapper, right? All the wrapper will have to do is just literally run. Oh, and we don't need this garbage anymore, right? Because we're writing everything. If f return, right? We don't need that. Whoops, don't format. Cool. Yeah, so now should be able to run this without the environment variable. And so we remove error and data.bin and rerun this. I forgot how you search in bash. We'll just use up arrow. Yeah, now we get the same data, E5, F2. This is good. So yeah, so literally we'll just have to run this and then set up the piping to be correct. So yeah, this was, let me just delete some of the stuff here. Okay. So yeah, we'll just move this stuff over here for now because we're going to start a new Rust project. So we need cargo new dash bin. We'll call this steg client. We need a better name though. That's kind of a garbage name. So vim source main. Dash I will hard code that path. We'll call it user facing logging, right? Is for processing, right? Cool. Okay. Okay, that works. Okay, I always hate the process API from the standard lib. Oh, and I don't know what's up with my LSP. I'll just copy, not this one. What is it? Rave. Like .nix here. Yeah, it just does the Rust source path. And we have to add it to Git for this to work. And we'll just pop this guy open. Okay, so it's downloading. Yeah, so now we'll get the Rust, all the Rust stuff. I think it's missing my default install is missing Rust Analyzer, and this is just a nice way to make it stable. I guess we don't have any weird native deps, so really there's no need to Nixify this. But yeah, it's just easier for me. Okay, adding input. Come on, buddy. Interesting. I thought this would be cached from the other project because it's literally using the exact same hash of Nix packages. So, okay, nice. Right. Okay, sweet. So now main. Yep, and we get IntelliSense. Sweet. So std process command new. And this is going to be. So this is going to be running from this directory. So it's going to be //c. We should make this like a command line argument, but we'll hard code it for now. David build. What's it called? We literally just had it. Oh, tools. Okay. Tools, yep, and that file exists. It's a binary, yep, so we'll just stick this path. It is a really gross path in here. Okay, so we're gonna add args. Actually, do we need args? We literally just want to run. Okay, so yeah, we do need args, so -I. And then this is gonna be the same thing, file, /, rave data, whoops, winter forest .I backup. Yep. Okay. So then this path. We'll fix that later. So yeah, we specify the args. So standard out, we're going to want to pipe. Yeah, pipe it so we can read from it in real time. So it should be IO. Or is this? Oh, SDIO, not SDIO. Whoops. Yeah, we don't need that. Process. Yep, pipe, and this is a function. And also, does this return self? Okay, so yeah, I guess we can. Do we have to? Yeah, okay, wait, I guess we have to bind it. Oh, and there we go. We need that. Yeah, so we have the args. We pipe. We'll pipe std. So actually we probably want this to be standard out inherit, so that way yeah, we'll just do inherit for now, and we can always change that later. That way we can kind of see what it's doing, just make sure it's not like crashing or anything. P dot spawn. We'll unwrap for now. And okay, and then we're gonna basically want to read. So child dot stdout dot unwrap. Oh, actually dot take. Then we'll do like let. Yeah, and then I'm thinking we literally just do read exact. So 32 bits of the pub key. We'll read all of it. It has to be mutable. It has to be, everything has to be mutable, I guess. We read exact, and then we'll just dump it out. P dot. Can we? I guess when we control C, it'll probably kill the child as well. That's fine. So yeah, I'm just curious if this will work. So yeah, let's do it. Oh, so okay, this is actually good. We're doing inherit, right? Because now when the child runs, yeah. So we forgot the dev null output. The problem was if we did this as piped. Now it's just failing for no reason, right? Because we can't read the buffer. But really, it's happening silently because we're missing this error program or this error printout that's sent to stdout. So actually, yeah, this is definitely the right way to do it for now. And we also want to do .arg -o /dev/null, right? So that way we're not. Yep, special character. That's fine. Cool, and that's. not sure if that's right. I think we print this out at some point, right? In main, got server pub. Okay, right, this should be, oh, we have to send this. 47229. Oh, this is right, yeah, okay. So yeah, we get the server pub key. Now we want to do the encryption stuff, right? So we're going to go to this guy, make this way bigger. Oh, my copy and paste doesn't work. That's unfortunate. Yeah, that's awkward. Yeah, I could basically go into visual mode, and I had leader C with copy. These with mouse mode, I don't think I can control shift V with alacrity, no. Yeah, that doesn't work. I can just look at this on GitHub, actually. Look at the fork. Source, bin. Oh, we're on the wrong branch here. Steg. Yeah, now we got our server. Encoder works. Server public. Yeah. Okay, so this is where we do everything. We're going to want to steal basically the same exact logic. Basically from here onwards, where we do the Diffie-Hellman stuff. And we're going to add this crate. What's it called? Yeah, eventually we're going to want get random, so we'll just add it with that right away. Yep, public key. And so this is actually going to be the inverse. So the client public, so in the current form, right? So we should have this client public. Yeah, so right now we're just setting the client public to be all zeros. Oh, that's awkward. Okay, we're going to have to rerun this real quick with a actual private key so we can know what the private key is when we're creating this. So let me think about this. Okay, yeah, we'll just do this for now. Client secret. Yeah, we'll just have all the keys be 0 for now. That way it's easy to figure out what's going on here. And we'll just rerun this guy. Outputting to, yep. Oops, hidden offset. This is 0. Oh, and we need to remove this. Okay. Oops, okay. Shoot, so we read in the client sends its key. Param. Yeah, so actually I guess we totally ignore this param for now. Because we do Diffie-Hellman with the client public. Yeah, so this is just a formality, basically. Right. So this should be the same as what we had before. 47.229 for the server's pub key. And it's, yeah, we're ignoring that for now. That's fine. And we're outputting the bytes here. Hold on, are we... Actually, no, we do want to output this. How do we change this easily? So yeah, actually for now we want to... we'll just set this to none and do a quick run. and do a quick run. And we'll do the regular file. We don't want to use the backup or anything. Okay, and this hex stump should quit on us. Because it'll either be... no, actually it won't quit on us. It just won't print anything. So we send this. Okay, so that it's definitely being sent to the file. That's good. We're encoding. Okay, we can put this back now. Now that we should have a file to work with. So, except it's not backup. Yeah. And it should be growing, right? 514, 542, sweet, okay. Yeah, so now we have a new file with a known public key. And if I end this, what will happen? Nothing, it shouldn't matter. Whoops, let's just see back into array. I think we have the data. Yeah, we ignore data, that's good, okay. Hardcode keys for now, right, push. And we should get it with a new commit. Yep, hardcode keys for now. Server public. Yeah, so now we know everything. So everything's hard-coded. Yeah, and we can do our Diffie-Hellman. So actually we'll get rid of all this crap. Yeah, so for now we're ignoring the server pub key. Eventually we will want to use this, of course. Whoops. Oh, and we want, we'll just do it in, I think it was shared secrets, right? Nope, or maybe it's secret. Ah, that's very annoying. Oh, static here. There we go. Oops, and let's get rid of this crap. Alright, so now you should stop crying. Yep, import. So we have our fake keys here, server secret. And this is actually be client secret with now the server public. So this is technically encrypted, but all the keys, the actual, both private keys are 0. So yeah, now we can actually do this. Yeah, so we're gonna loop here. Did we extract the, so yeah, we read this, we have the raw bits. We'll just do like, we'll read 128 bytes at a time, sure, for whenever this gets run. We don't want to use a buff reader or anything like that because it's coming from standard out, and so we just want to get data immediately as it's available. And we'll do, we'll read into buff, and we'll have to handle the error. And then we'll just grab the bytes we did read. And we're just gonna allocate n bytes. We can optimize this later, that's fine. Now we want to create our thing for encrypting, right? So where do we do this? Yep, apply key stream. So yeah, we need the same nonce, that's going to be important. The server public. Okay, yep, and we'll apply the key stream. What do we need? Oh no, we're only sending that, so we only need this stuff. And we want to create this once, of course. Cha-cha 20. And we'll import this guy. And so the key is going to be our shared secret again. Nonce is going to be the same. And then here we're going to Oh, it's already mutable, actually. Yeah, we can just apply keystream on the n bytes we did get. Yeah, and that way we don't have to keep sub-slicing here. And then we'll just do like lossy, right? So we can just kind of see what's going on here. We'll debuff first. Yeah, so we'll basically do the raw bytes here, and then the string if we do get it. Okay, let's see if this works. This guy should be done. Nice. That wrote to this file, which I want to make sure we're reading from. Nope, we're still using the old one. So I got to change that. We're sending it to devnull. And yeah, let's see. Come on. Okay, so then it looks like it stopped reading. So if we can't read anymore, I think if this returns 0, it should mean EOF. Okay, yeah, so. Okay, then here we should like join. So we're already piping equals child dot wait. Okay, and then if it's not success, right, and then if it's not success, we'll fail. All right, so yeah, it shouldn't fail, and we break if it's 0, and we should get a null byte at the end, hopefully. So we read exactly server pub key. Seem to be getting a lot of bytes here. Okay, so the pub key looks right. That's good. We're getting that from, yeah, we're getting that from the bit stream. That's good. Got bytes. We should actually probably just remove this logging from this to make it simpler. Are we running an old version? And this should be the decoded one, yeah. And it looks like we're reading one at a time. That's fine. It looks like we're getting way too much data, though. Yeah, there's still something wrong here for sure. This is definitely not a string. That's not good. So the shared secret should be the same. That should be a thing, right? And then we can do that over here also. And we'll write to just a different thing so we don't mess it up. Oh, waiting for client. Yep. Okay. So now, got shared secret. Okay. Yeah, so now if we rerun this guy, we should hopefully get the same shared secret. Okay, so the shared secret's the same. So the decryption should work, and it's a stream cipher, right? So yeah, we send this. Let me just make sure we're encrypting correctly. Right, so we read payload bytes after cipher. And then the payload is literally just the payload bytes. So this might be something to do with when we switch between the two. That's what I'm thinking right now. Yeah, and then we don't need netcat. And yeah, we'll just ignore the output. Okay. So hopefully we should see the same bytes here. So it looks like this is the first read. So this should be HELLO. Wait, what are we running this with again? Hello YouTube, right? So this is maybe HELLO space YOUTU. It's not the whole thing though. $181. Got bytes 10. Okay, and then before, we obviously don't want to print the string because it's going to be garbage anyway. Oops. We'll just make a mutable reference here, and then we can just use buff loosely, right? Okay, this does not look right. So I want to, instead of doing this cipher stuff, I'm thinking for the payload, we just replace this with like 16 bytes of zeros, right? And I'm gonna want to, this is getting annoying. Because now we do want to save this to the file, right? And where does that happen again? Box. Yeah, we can just do this. So if true, yeah, so if true, we'll do none, we'll write to the file. And this should be, yep, winter forest, we should be looking at the right one. Let me just make sure we're running. Yep. Okay, we're up to date. That's good. Yeah, so let's run this guy again. Waiting for client, okay. Yeah, and you can see it's injecting a bunch of zeros, and now it's done. Right, so we should be able to read this on the output now, if this is working properly. And so yeah, we switch to new data, and then it gets all zeros. So that makes sense. That should be visible from this guy. And so now the before cipher should be all zeros after we read the server's public key, or the client's public key. Whoops. Looks like we're still getting junk though. That's interesting. And we are using the right file, yeah, and the right binary. It's funny though, because we are getting the correct public key, right? We do read exact. We look at however many bytes we get. Yeah, that's very odd, guys. I'm not sure why that is. You know, instead of doing this weird double thing, I'm thinking we literally just concatenate the two together, right? I don't know why I didn't do that in the first place, because we know the length, right? And we have all the data up front. That was really stupid. So yeah, let's see here. Is it do? No, what's it called? We'll just go to cipher. So we're going to take the server public, and then the payload. Yeah, so we never actually needed this weird double thing. Oh no, this is going to be hic just data. And needs to be copied. Okay, I suspect this might actually work now. So yeah, we should be writing to the file. I'm going to remove it just to double check we're doing the right thing. And yes, be the same nonce. The shared secret is the same. We're asserting that. What? Yeah, okay, the shared secret's the same. Not open. Oh, shoot. Did I delete the input file? Oh, that was such a pain to make, guys. It literally took like so long on FFmpeg. Okay, well, I know the path, so this might actually work. No, there's no dash, what can I call this? Oops, that's not the right thing. All right, so thing is, I have the encrypted block devices, right? So, okay, it should be under root. Dev mapper root. Test. Oh. I hope this doesn't delete everything. I don't want to unmount my whole file system. Oh. Guys, hopefully I can find my FFmpeg command. This can be a pain. This is kind of a sidetrack, so I'll be back in a sec once I can recover this file. All right, I'm back. It wasn't as nearly annoying as I thought it would be. It was just one FFmpeg command to redo it. Yeah, because it needs this weird. It has to be in this source format, like AV420p, and I had trouble before because it wouldn't respect my bitrate setting. And originally I was just trying to transcode the whole thing, and so take forever and use a bunch of disk space. But I'm just using the first 8 seconds now, so it should be fine. So yeah, so if we can now delete. Wait, IVF. Gotta make sure. IVF. Yeah. Okay. That is the destination. So if we re-encode, waiting for client to connect, we can send this, and yeah, it starts injecting. We should be able to see. Yeah, this should be all one go now, because it won't be switching off anymore using this chain thing. So yeah, it looks like it's encoding. I'm just going to control C it now here so it flushes out whatever data it has to make sure we're in a good state. And so now if I run this guy, let's see what happens. Okay, so we get, let's see. Come on, buddy. We should be able to do one big read here, like pre-cipher. Okay, so it gets the right shared secret. Okay, so before cipher is this. Shared secret is 147. Yep. This shouldn't depend on length, so I'm very confused by this. Before cipher 72. Alright, let me just make sure. Got shared secret. All right. And just double check. We do want to write to disk. Yeah. Okay. And it's this.ivf. Nice. Okay. So these are the bytes we're injecting, 48 bytes, which are 16 for the payload. Yeah, 16 for the payload, and then the rest. but this is going to be ciphered. So we should expect to see these come over the wire from the angles when we read this. Actually, let's change this to do read. Yeah, we come up with the same shared secret, so this should be identical. Is this the same here? I'm curious that we're dumping. Ends in 117.243, yeah. So if we follow this all the way back to this 72, 1, 2, 3, 4, 5, 6. $72, 110, where's that? We have wrapping on, yeah. Are we not injecting that? What? 243, 202, 77, 94, 68, 164, 22, 106, 232, 76, 36, 221, 129, 78, 86. Okay. Yeah, so it looks like we're getting the correct thing. This is after ciphering, right? So that means we should be getting this with the null byte after unciphering. Except we don't. Yeah, and we're making sure the shared secret is exactly the same. Right, because we have the client secret, which is this. These are both 0. And then on the server, yeah, we use the shared secret to make the cipher. Yep, and then the nonce is 12, 0x24 12 times. Yep, that makes sense. Yeah, guys, I'm not sure what this is. One thing we could check is if we clone it, right? That's annoying. Okay, let's say we just create another one, right, with the same thing. So before cipher, right? So if we apply the cipher to the cipher text, right? Which is this too many bytes? 17? No, okay. Yeah, so we make a vec here, these guys, and we do c2 dot, what's it called? Keystring. Yeah, then we should be able to assert if we're giving it the cipher text, we should get back the plain text, right? Oh, not C2. Test. And why are you crying? What? We're taking a reference to it, though. Oh, dref is not doing us any favors, I guess. It decrypts fine, though, so I guess we're just not reading bytes correctly. Huh. Read exact. Yeah, I don't know why the keystream would suddenly change and be invalid.
we can also assert, so everything up to the 72, where this guy starts. Where does it start? Yep, so we get the same shared secret. Client, server. Maybe there's like weird buffering that's happening. I have no idea what's going on, guys. We're using the same nonce. If we decrypt using the bytes, it's fine. We apply it in place, yeah. This is really weird. And we should be able to verify that the server's pub key is the same, right? Because then at least we know we're reading from the correct thing. Got shared secret, server pub key. Yeah. Yeah. Okay, so we can decode the server pub key correctly. Thing is, though, what happens after this 116? That's what I'm worried about. Okay, so if we just run the same program directly. Build tools, David, AV1, data, winter forest, IVF. And we pipe this to data.bin. Actually, this should just redirect standard out. We should get all the same stuff. So we hex dump data.bin. I must want to hex dump decimal because that would make a little more sense here. What is that? That's crazy. So yeah, their file is b.c, so this should work. Okay, except this is signed. We want unsigned. This would be, if I was better at Python, that would be pretty helpful, I bet. -C, yep. we could also just convert these asserts into hex. That might be simpler also. Actually, yeah, let's do that. Yeah, so when we're printing stuff out here, the raw bytes, injecting yeah, and so we only cipher the payload bytes. Before cipher, we print that out. Yep, okay. Let's try this again. Okay. Yep, so before cipher, here's our ASCII. This is what we expect to be in the file. This is the whole thing. Yeah, so we can verify that the server pub key is not the last 16. So 1, 2, 3, 4. All right, let's try this. You go here. Okay. And this is server pub key. So 2F E5. Yep. And it should end like this, the last 16. After 3B74. Yeah, so this should be what we read. Okay, we can do another test here. Yeah, so we start with this ciphered data. And we hexify it. Right. Using the same shared secret that we verified is correct. Yep. If we apply the key stream and print it out, it should give us. Yeah. Okay, so it must be something with reading the angles. That must be what's throwing us off at this point. And let's do this in hex also. Okay. Okay. Except, there we go. Okay. So, this is where, hold on, let me get this correct. Yep. Okay, so this is where our ciphered message starts, right? And the server pub key ends with 7.4. And then the next line is supposedly our message, or our thing. You know, the first thing I'm going to do is just undo this weird double X stuff. Because we really don't need it. Yeah, and then these just all become hic new. Okay, so now we don't have that. We have no weird branching logic. We're going to rerun this. Our parameters are the same hidden bits and hidden bits offset. Yep. Yeah, because technically the C code is extracting this, but we're getting the right thing from, what's it called? So it has to be correct. I'm going to make these all hex real quick. Yeah, so this should be A-okay. We're still getting this AD crap. I don't know why. Yeah, if I run it on its own with just data.bin. Still getting AD. Yeah. 93 FE. That's weird. That's not hex at all. There we go. Yeah, so it seems to be right all up until so 3B74. This next byte should be 56, and because that's what we're doing here, and it decrypts fine. But instead it's AD. Are we skipping a bit somewhere? Because we just inject continuously, right? We skip some angles. Yep, this works. This is known to work. Huh. Yeah, I don't know, guys. I have no idea, genuinely. Again, we chain payload bytes. This is our text. After cipher, we get this, which we chain. Yep. The config's the same. Yeah, dude, I don't know. This is very frustrating. Yep, I'm stuck here, so I'm going to take a break. I'll come back when I can figure out what's going on. Found it, guys. Turns out I'm a total moron. I was running it with this 2 file for literally no reason. So I just had some test code where I just put a set value a bunch of times, run it, connect the client. Yes, override. You can see all the bytes going in. We can kill it now that it's encoded. And if we re-extract it and dump it, you can see it's now what we expect. So I was just literally using the wrong file. I was really stupid. So I'm going to undo like all this crap. That must have been an hour of me just sitting here racking my brain. That was unfortunate. Let's see if we can go faster here. Yeah, basically we want just the base thing where it was like doing the ciphering before all this like weird. Oh yeah, success. Apply key stream. Yeah, none of this assert. Okay, I think this is what we want. Yep, random keys. We read, apply key stream. Okay. Yeah, so if we go back now and just get rid of this example code, write it to the correct file this time. Client, overwrite, yes. Angle, blah, blah, blah. All right. Now, oh, there's no null byte. Yes! Let's go! Okay, and we get the null byte. So we can, we'll go through the whole thing. So if buff.iter.find, this turns an option, b equals 0 as sum. We're just going to break, right? Because that means we hit the end. And we got to dereference byte. What are you crying about? Oh, it's a double. Oh, that's annoying. Okay. See, if I run it, we get just this, right? So now we can ditch a lot of this debugging stuff, and we can just print. We'll just print literally just the buff. That's question mark. Nice. So let's, we can get rid of some of these debugs. I'm going to do kind of the same thing where I print line for debugging. And we'll just do regular print for this, right? So if I do like, I forgot it in fish, whatever. But basically we have the ability now to avoid this stuff. So yeah. So now if we were to run this with like, let's say we just find some lorem ipsum, right, just to double check this. Where, oh, here we go. Yep, for a nice type setting. Needs. We go here. Paste it in. Client. Go. Yes. Big data, lots of injection. All right, we can kill it. Now, whoops. Yeah, we get it. Was do the last thing? Do we? Oh, I think we had an error. It looks like somehow this got replaced with a null byte. Oh, are we breaking early? That's interesting. So we read as many as we can. Play the key stream. This is a loop though. Yeah, I wonder if maybe we just had an error. That wouldn't be good. Yeah, I guess we could expect an error eventually, you know? And it looks like this is, yeah, ciphered. This is all looks, oh, shoot. We can't do null bytes, right? Because so the reason this is failing is I bet there's a 0-0 right here, because sometimes we're using the full key space, right? Because this is a good cipher algorithm, presumably. And so eventually we're going to encrypt something to be a 0. And then that means we can't use it anymore. We could do something like if we see a bunch of null bytes or, you know, something like that, then we do it. But no, this should be post decryption. There should be no null bytes in here. Huh. Wait, why is it still injecting if we're not? Should it not inject all of them? Oh. Does it slow down over time? That would be interesting. Yeah, it's still injecting stuff. Maybe we need a bigger carrier file or something. It's very odd. I wonder, I have no idea why it would actually slow down like that. I guess we just got to sit here and wait if we want to move a lot of data like that. Let's see, I'm going to print out, so I'm just going to print out this. Oh, because we're not flushing, maybe? Do a stolo. I'm not sure if we finished the entire thing. Yeah, I don't know. There could also be an issue with our C code, maybe. See how many frames? Yeah, 240 frames. So yeah, I guess it does slow down over time. That's interesting. I mean, this takes a lot of time to encode. I don't want to sit around and wait for this. Yeah, so I guess that just puts a cap on how much data we can send through this, which is fine. Eventually, if we have a full live stream that's going and going, we'll have enough of a carrier. We can keep injecting bits. But yeah, I'm happy with this. So let's switch to actually using the real keys. So our client secret, we're gonna have to open the TCP stream here and send this. So we're also gonna have to somehow stream the AV1 file to what's it called, into the C program. That's gonna be, oh, we can probably just use it standard in or something. Yeah, instead of this. Yeah, so we'll just do standard in, piped, so we can get its pipe. And we'll just grab this. Okay. So our client secret, we're going to do this. We're going to generate it randomly, which means we of course have to send our public key. So yeah, let's take a look at this code. Let's see, what do we fix? All right, so it's going to be basically the inverse of what we do on the server, right? So we refresh this guy. Yeah, so we'll actually just copy this whole thing, basically the whole task, so we know what's going on. So this is going to be like send socket and do we have anyhow? Yeah, we're going to want error handling eventually. Anyhow result. Socket is going to be TCP stream, except we're going to borrow it, so we have to move it. We don't need this, we don't need this, or this. So this is going to be set param we'll wrap this in a buff writer actually. Yeah, and then we don't have to do this. So we're just going to write, we got to import the trait. Why are you crying? Oh. This is going to be public as bytes.len as, and we'll unwrap. These don't need to be mutable, and this is going to be use16. And we're going to write param length. To LE bytes, right? Right, so now we know the length. Now we can write the whole thing. So socket.write client public as bytes, right? And it's nice because this resizes what? Oh, we're already unwrapping. Duh. Okay, well. Okay, we're at the public key. So now we're going to do socket.flush. Right now, we do this in the other file, vhelman. Then we just have to send the start command. So actually we can do that here as well. right? Yep, then we send it. Cool. And then we loop and read from it. Then we need another thread to proxy the data to, what's it called? Yeah. So we're going to say let equals proxy AV1. And this needs, we need a split. Is there a split in the standard library? Maybe not with the buff, right? Oof. Oh, okay, we'll just clone it. Easy. Okay, we do have to set it to a variable though. Stream. And then we'll just give it socket. This is going to return join handle of a result. Okay, and what we're going to do, these need to be mutable, right? And we'll just do reads as big as we can. It doesn't need to be wrapped in anything. So we'll do big reads. And then we'll just write it all. Yeah. Oh no, actually we can use copy, right? From does this tell you the number of bytes? Yeah, okay. Okay, so we proxy that. That's good. And I guess we can join this at the end. And this works because the input's from the socket, which... Will that close automatically at the end? I'm not sure. It's fine. We'll just let it... we'll let it die. Okay. Because yeah, if anything, this will close. The standard end of our child will close when we join this. Okay, yeah, actually that'll make it work. We'll just join this guy. Okay. Who's crying? This is socket. This goes like this. Okay, connection refused. Nice. So this doesn't need to be mutable, and all we have to do now is send it back over the data back over TCP, right? So where does that happen? So we're gonna create the box. Okay. So instead of none, we're just always going to override it to point to the socket. Yep. And so now we'll just run this with YouTube. I wonder though, in parse CLI, right? Oh no, we need the socket override anyway. Yeah, it'd be nice to disallow this input file, or sorry, the output file, if we're writing over the socket, but that's fine. Okay, let's put this here so we can see it, right, when we run it. And let's see what happens. Didn't copy anything. Interesting. Oh, are we sending the wrong bytes? This needs to be 0. Yeah. Okay. Run the server. Run the client. Connection reset by peer. So we definitely send a 0. That's odd. Is this not? Okay, here it flushes and resizes. That's odd that we definitely write a 0. Is this connection reset? An IO copy, interesting. Yeah, that's not good. Very odd. How is it decoding frames, though, if it wasn't getting data? Wave server 40. No, it's 40. Oh, 402. Yeah, this is the very first thing we read. We make sure it's 0. Here, we're definitely writing a 0. Is there a write all? So maybe it's getting dropped somehow? That would be very odd. What the hell? Actually, what the hell? Okay, if I write just this, and then flush the socket, what happens? Right, so client connected. Received. Right, so it should block on this after this print, right, if I do this. Oh, what's this? Oh. Maybe I'm sending it too fast? I don't know why that would be an issue. Yeah, very odd. Yeah, I guess it's just it can't duplicate the file descriptor. Yeah, FNCTL clone. Yeah, very odd. You know, maybe instead of doing these writes, we could like make a whole thing. Buff. Oh, there we go. What do we get? Corrupt. Nice. Broken pipe. Interesting. Okay, so we need to handle this gracefully. Except this needs to be standard in. Only pipe standard in. Yep. Yeah, so this must be failing because it can't get all the data, right? Mixer threads. Huh. That's odd. CLI parse. Ooh, get opt. Let's go. This is the OG. Except we have to... Okay, put open. So we want to open a file pointer to standard in. Oh, okay, so we can just use that constant. Nice. So if we compare and it's a dash, how does this get so messy? What? Oh, here we go. That. Okay, so f equals this, f equals standard in. This is a file. It's 6 turn, okay. Yeah. Yep, read binary. Rebuild this guy. Oh. I do this to get rid of the warning? Okay, nice. Oh, I guess not. How is this even a thing in C? Like, I still don't understand. This is actually crazy. Okay, so that's fixed. So if we try to run this, except we do standard in, dash I, boop. Reading it for standard in. Okay. And so then if we echo yeah, so basically echo ends up closing standard in once it finishes writing. So this is definitely reading from standard in, right? Because it's failing here. So we can actually delete this log. Yeah, we signed to it. We'll initialize this to null anyway. Okay, so now this should let us read from standard in. Except why? Okay. Okay, send pub key. Write all flush. Are we on a different port or something? Seems like the client never connects. Piped. Where do we get stuck then? So this makes sense. Yeah, so we have to read, we have a deadlock here, right? Because the server's waiting on us to send our pub key so that it can send its pub key. So we can't do this after. We have to do this after we send our pub key, because we read server pub key, right? Yeah, and then we'll do Diffie-Hellman and create the cipher after we make the socket. Let's do this. This better just... Yeah, okay, this constructs it directly. Oh, shoot, and we were modifying this. Oh, I guess we're editing it here as well. Let's not do that. All right, so we create this stuff after. We do our Diffie-Hellman. This from generates, just dumps in the bytes directly. That's what we want. After we read the server key. And we'll just print this out too for good measure. All right, so now no more deadlock. Did it work? Broken pipe. Interesting. Okay, it definitely looks like it was injecting stuff, which is good. Who failed first, though? That's what I'm worried about. Broken pipe. The server should respond after this, though. Oh, maybe we have to flush on the server side, perhaps. Oh. What? What do you mean failed to open? Huh? Yeah, so I guess if it closes early, then it gets mad. So this is unrelated. Unexpected end of file. We get that because the server hangs up. And why does the server hang up? Probably because it's done. So I think it's literally just because we're not flushing. Send. Okay, it happens up here in this task. Oh, whoops. No. I'm stupid, guys. No, this is the standard app. This should work. Yeah. Why is it not getting all of that then? I'm going to delete the output file just to be safe. But if it errors, I wonder how many bytes it does write. Huh. Can we implement this? Is this an easy? Yeah, let's just implement this ourselves, honestly, so we can see what's going on. Alright, so we need to read from socket. And now we need to loop also. Okay, we read n bytes or whatever we read. Okay, let's try this. Okay, it is definitely getting data. right? Where did it panic? Here. So I wonder if there's something special about that number of bytes. No. Okay, that's not... That's curiously similar. Even failed to open. What? Section 5. I wonder why these are all different, though. IVF open. Okay, so these are... Looks like this is just the generic demultiplexer. Okay, let's do a little test here, actually. So if we do like cat, what's the input file we're using? Winter Forest. Okay, we use the backup. Okay, so that's why. I wonder if this is the one that's running. Yep, okay. So we just need some branching here. Actually, let's write it like this. Okay, so it is this. We handle that by setting CF equals standard in, right? We don't need dingus anymore. Equals 0. Floating point exception. What? What? IVF open. This is probably me, IVF open, yeah. Oh, shoot, okay. This can't be if else. Okay. Yeah, so it is we assign it. Okay, so we're going to use standard in if this matches. If it is, we set up this, and so if we're not using standard in and this stuff, then we want to fail. And then once we get here, CF is guaranteed to be initialized because either we're using standard in, and so it's set here, or we're not using standard in, and so it's set here, or if it doesn't get set here because it can't find it, this code will execute. Yeah, okay. This should be solid. F read CF. That's very odd. Is that because cat? Oh, Valgrind might be messing this up here. Let's just run this normally. Make this even smaller. Okay. Is that the same error we got here? Bad file descriptor. Interesting. Standard in is piped should mean we get to write to it, right? Yeah, we definitely don't want inherit. We don't want null. Piped. Interesting. Pipe as standard, that's right. So weird. Yeah, we're going to have to change how we do this, guys. It's very annoying. Okay, so STD we pipe. Yeah, and we proxy the data to standard in. So if it is this, STD and read binary. Okay. Come on, buddy. It's running, apparently. Oh, he's just not... Oh, that's going to be tough to debug, guys. And then we write to standard. Yeah. Yeah, guys, I'm not sure. Somehow managed to really botch the C code, I guess. Okay, so we say read and entered in. We sign it. Can't assign it. And we fail. And then we always try to read the header. Okay. Are you kidding me? Like, what is this, bro? Yeah, I can't even debug this with, yeah. Huh. Oh, duh. Okay, yeah, we can just do normal piping. Yeah. So we're gonna run, input, standard in, output dev null, output to data, and then we're gonna read from this guy. Segfault, where? No debug information, great. And I have no idea how to use Ninja, guys. Where is this? Oh, I really don't want to modify their stupid build scripts. You know, I'm so glad I haven't had to deal with C and C++ in a while. Okay. Okay. There we go. Okay, this should be better. All right. GDB run. In fread. Interesting. Oh, maybe this return. Oh, shoot. Yeah, this might be failing, guys. And this is standard in. Yep. Yeah, we might have to find a different strategy here, guys. I don't know why this is happening. Maybe I can't use this. Oh, no. I hate that. Oh, I've done this before too. Oh, that's so frustrating, guys. Oh, that's by default. What? Okay, so this should only change it if it's not there, right? Yeah, sref unwrap or. Huh. Yeah, it's not Rust, or at least it shouldn't be Rust. Yeah, guys, maybe we have to create like a named pipe or something, because I don't know what's going on with this. This is terrible. I don't know how this is a bad file descriptor. That makes absolutely no sense to me. I wonder if somewhere this is forking. That could make sense. Yeah, read binary. This is fine everywhere else, right? YUV open. Oh. change this? Oh, maybe there's... shoot. I did this. Include. Maybe there's another command line argument for it. Shoot, guys. That's unfortunate. Input. Yeah, we probably want to use a named pipe then. Okay, I guess we got to do this then. That sucks. Let's try to undo this then, because this isn't working. This is getting wrapped up in all of our other changes, though. It's not good. So yeah, we write the bytes to standard out. Okay, we want to keep these changes, the angle stuff, and we want to restore these. Ooh, nope, we don't want this at all. Here we'll use their convention. Okay. Let's just redo this whole thing. CD build. Setup ... Oh, that's nice. It stops you from doing that. Ninja. Yep. Okay. Piling. And this should be optimized as well, which is good. Okay, so we got to figure out how to do named pipes. Okay, I think this is what we want. And so we want this in the client because it's going to be the one running the decoder. Oops. Yeah. Right here. And this is going to be let. Okay, yeah, like this. And we can just copy some of the example code. The problem is you want a full path to this. Yeah, I hope it doesn't need a special API. Ooh, FIFO or Oh. Okay, I guess it's literally just named. It's in every directory, I guess. AV1. All right. Okay, hopefully the libc functions just work for this, because we're going to read in this guy. Pipe, yep. Open or create, okay. Okay, then what's the API for this guy? Oh, okay, we'll just do create. Then we don't have to manage things. Is this, I wonder if, does this do to randomness? Okay, yep. Okay, and then this is going to be pipe path, which close. Oh, this implements read and write. Okay, sweet. Nice. Yeah, so instead of standard in, we're going to have standard in be null. Standard out we need piped, and standard error we want to read what's going on in case there's errors. So we give it the pipe path. We should like print this out as well. I think the debug implementation for OS, okay, that works, yep. All right. So the pipe path, and then of course, we no longer have this, because that's going to be none. And this is going to be pipe. And these can really just be we'll just make this a little bit nicer. Oh, whoops, this is read. Okay, whatever, we'll just change the actual types. Oh, he's just to own it anyway. Okay. And we don't need this guy anymore. Alright, let's see what happens. Open path. Does this get set to name? Oh, it's with the process ID and that. Ouch. Looks like it creates it by default if it's not there, so that's good at least. Okay, I think we can just hack the path actually. But we don't want to format this to be whatever. It's fine. It's fine. Problem is it doesn't implement display. Yeah. What does the name return? Okay, it should always be UTF-8 because we're only generating alphanumeric characters. Okay, so this should be temp slash, and you can inline this guy. All right. Come on. Come on. It's not an IVF file. Interesting. We were able to write a good amount of bytes, though. I don't know how to use this thing. Is there an issues? It's awkward. Awkward, very awkward. Okay, this seems like the right way to do it. Okay. I wonder if I can just download this as like a diff. Nope. Well, whatever, we'll just do it manually. That's more fun anyway. Okay. So, just making sure, yep, we don't have any changes. We add this at the top. We need this function before input open. Should just be the same probe size stuff, right? Yeah, okay. Why do you rename it to file name? That's interesting. Oh, he has to do... not res after we free the probe data. And we have to include this guy. And we also have to unlink it here. What else changed with this line? Data. Oh, okay. That's important. Simple open, less than 0. Oops. All right. So this should work. Let's look at RDiff. Okay, binary mode stuff. Set binary mode. File fname. No more opening like normal. We should fix this formatting. Okay, this is all copy pasted. This is fine. Change this to use fname. We sign fname here. We sign fname here. Okay, reasonable. File name changes here when we fail to open. We unlink here. What about probe demuxer? Okay, it's supposed to be fname. But on the next line, on the next line we also unlink. Then we calyx stuff. Yep. unlink there. And then this is fname, and we unlink at the end. Okay, that looks good. Do we set fname? Ah, we do. Okay, so this needs to be declared up here in case we need it, right? Nice. Good job, compiler. Okay, let's hope this works. Okay, so if I rm data.bin, rerun this, we seem to get reasonable data. Okay. So yeah, I think the standard in stuff should work now, so we can redo this pipe crap. Pipes, no pipe. Yeah, we want this. Okay. All right, let's go. Don't fail, don't fail, don't fail. Yes, yes. Come on, buddy. Come on. Okay, it doesn't seem to be immediately failing. That's good. We don't seem to be getting any of this, though, which isn't good. Should be done by now, though, so I'm not sure what's going on here. Yeah, I'm gonna let this run for a bit, and we'll see what happens. It's still going. It should exit soon. Yeah, it's only 240 frames. It'll exit in a second here. Okay, and we need to handle end of file here. Oh, yeah, and then if it's an error. All right, another 2 minutes of waiting. Let's go. This is really slow, isn't it? Yeah, it's doing like 2 FPS. And it's like, I wondered, it seems to be taking it, right? So this is going to be yeah. Yeah, this doesn't seem to be doing anything at all. Yeah. Oh. So maybe we can't write this in real time. Right? Or maybe it expects... Does this code expect to read it all in one go? Oh. That's not going to work either. That's actually so frustrating. We literally can't stream this at all. Nice. Oh, and we can't do it on pipes either. Great. Yeah, I guess we're just screwed. Yeah, so the thing is, if we can't do it in real time, right, then what's the point of... Well, I mean, maybe it did work. It at least seems to be doing stuff at the very end. I mean, I guess it is able to decode it, right? Once it reaches end of stream, and it can write the whole thing out. Yeah, it's reading this. It actually exits successfully. That's nice. The problem is, right? Send it to standard out. Oh, these must be all the old angles at the end of the file. Here. Yeah, if I scroll up, we should be able to find the actual text as it's being decoded. Where's the FPS monitor? Got the public key. Is this correct? FE574. Okay. All right, and then it looks like it reads. Where's that bracket? Shared secret should be the same, right? Okay, well, FE2, that should be reasonable. C1. That looks like 224. Okay, so we generate our public key, we send it. The server should be using our public key now, right? Otherwise it won't work. Actually, so let me make another copy of this that's even shorter. It's like 3 seconds. Yeah, FFmpeg is super fast. I don't know why this library is super slow. It's super frustrating. Anyway, so we can get rid of these prints because we know it is working. It just has to wait until the very end, right? So I'm not going to try to work around this. I'm just going to, now that we have a shorter video, just get this working on its own because we got to turn this in pretty soon. So now we don't actually know the client secret. This will be random. This can't be 0 anymore. Server secret is random. Server public is generated based on that, right? Okay. Param, okay. Public key. Okay, and this has to, we have to copy this. Do we have that code? Did we delete it? Okay, so we read the param. Okay, and then we do this, our secret. This is the opposite, right, where we send our public key. We read the server's public key from the first bit of the stream, create that, then we do Diffie-Hellman with our client secret, and we send our public. Okay, so this should work. Our nonce is the same, right? And then we should print out, like, just to make it clear with like the locking and stuff when we actually get proper data, because it's gonna be fighting with this to print it. So, but yeah, this looks looking pretty good. So let's run this guy. What is it crying about? Uh, 102 rave server. Oh yeah, no more static secrets allowed. Good. Yep, same here. Nice, no static secrets. Don't need this either. Cool. And it looks like this is just about done. 2 FPS. So 3 seconds should be about, what, 90 frames? So yeah, we're almost there. That's not bad. If it takes under a minute to run, that's at least more doable for alternating. Yeah, okay. Okay, it looks like it got truncated. That's probably just because of the length of the carrier wave. Let me try running it again and seeing what happens. Because we are using up quite a bit of those bits for the server's public key, unfortunately. Interesting. That time we didn't get the server's key at all. Interesting. But it's weird because it seems like we inject everything at the beginning, right? So it should be trivial to read this back. Oh, we need to flush. No, that should happen on close. Yeah, that should happen on close because we're hitting the syscall every time, which is slow, but we don't. Luckily, there should be no buffering at all. Interesting. Yeah, I don't know why that is. Oh, let's rerun this so we don't. This guy's really fast. Okay, let's try it one more time. Actually, let's make this file just a touch bigger. Instead of 3 seconds, let's do 4. Thing is, maybe the bit rate is too small, kilobits. So this is 4. 4 megabits per second. That's not bad. Is that actually what the one I specified here? 2.5. No, I said something way lower. Let's try bumping this up, actually. We want this to be, let's say, 10. Yeah, once this is done. And this should be 120 frames now. You can see like when each frame ticks through from the size of the writes. Yeah, now it seems like we can't do anything. That's not good. Yeah, what if I bump up this bit rate? Yeah, it seemed like before FFmpeg wouldn't respect our bit rate at all. Okay, about halfway there. Yeah, that's really unfortunate, guys. Like, the whole dream of this project was to have everything running in real time, so you'd actually use this like a server and just like, stream video and use like, that's the whole point of RTSP, right? And so it's kind of a buzzkill that we literally have to like write it to a file or do something weird with it. And it looks like we would have to do a bunch of edits to the library itself if we wanted to actually to use it. Oh, but it works. That's the whole thing. Nice. Okay. Well, it's a little bit flaky, but I'm gonna call it here. Like this is encrypted, using a pre-shared key. They come with a shared secret, and we have this streaming inside the video. I actually want to see. Oh, I guess we can't, because it's over TCP, we can't see what the video actually looked like. But yeah, there is, oh no, the temp file gets deleted. But yeah, overall, that went well. I got to turn this in, guys. There might be another video on this in the future if I want to clean it up, or maybe we can look at a different decoder, perhaps, where we can do it in real time. That might be interesting. But yeah, the last couple hours were unfortunate, but overall, I had a lot of fun with this. It's pretty juicy code, and so I'll stick this on GitHub. Look for that link in the description if you want. And actually, this is probably the last assignment I'll ever do for college. So the speedrunning C, there's some more videos I'm trying to upload. I'm working on editing. But other than that, that's about it. So kind of the next steps for the channel are more of kind of videos like this, or like the dinner bill splitter, or some of those other kind of Rust videos where obviously I won't be going to school, so I'll just be coding for fun. So it's really whatever whatever projects I find interesting, I'll pursue. So yeah, see you guys around. Thanks for watching.